Hey everyone, kids, this is Dr. Callahan with week 2 Tuesday. How are you guys doing? I hope you guys are having a wonderful week. Go ahead and pause the video and answer the following 3 questions, or I could actually say, yeah, 3 questions, 1, 2, 3, for the warm up for week 2 Tuesday. So pause the video and go ahead and do that. Okay, let's go ahead and create the assignment for week 2 Tuesday for Algebra 1. Before I do that, just keep in mind that you guys have your grades updated since this week for week 1 Monday, or since week 1 Monday. And so this is your grade right now. It is posted on MS Team. It is categorized based on your student ID. So that way, you can access that, and it's pretty secure because it's just based on your student ID. Granted, this is only one grade that's inserted, and if you're like, ooh, how am I already getting an F right now? It's because you haven't checked in with me at all. Like, you have not viewed one assignment from week 1 Monday to Friday, and you need to make sure you're doing that. For those of you guys who are like, how is this person getting a 95%? It's because that person has been turning in their assignment and uploading their assignment on MS Team for Monday through Friday. So if you have a 50, that means you didn't do anything, because your grades, remember, are from 5 to 10 points. So if you get a 5, it means you didn't check in with me. You have not even viewed your assignment at all from week 1. And so you just get a 5. 5 out of 10 is a 50%. Okay. So if you have a 95%, it means that you probably viewed all of your assignment. So Monday through Friday, you viewed it, but then also you have turned in most of your assignment in addition to that. If you turn in every single one of your assignment and you did it well, then you will have 100%, which is a 10 out of 10. So just keep that in mind. But so far, your class average is a 62%, and you guys are good to go with that. Okay, so then with that said, let's go ahead and start the assignment for today. All right, so your assignment is for week 2 Tuesday, Algebra 1, semester 2. And today we're going to talk about exponential growth and decay, day 2. So, week 2 Tuesday, distance learning. Make sure you guys watch the video in its entirety. You need to have 45 minutes of instruction for this class. And remember, this class was reserved our first period, so you should be doing this between 8:30 to 9:15. I always do the attendance by 3 p.m. the same day, so you do have a little bit of wiggle room, but try to make sure you're logging on to MS Team between 8:30 to 9:15, because that's your reserved time for this class. In addition to that, make sure you guys are viewing the assignment for your attendance, but also uploading the assignments on MS Team for your academic grade. The link that you guys need for this class is right here. This is your channel for the YouTube videos that I have Monday through Friday. And if you need a hard copy, you're welcome to pick it up outside my class, B1. Right here, it's a table outside B1. It's just a tray with your warm-up log and also the first 6 weeks of your guided notes. So you're welcome to do that. You get 10 points every single day for this, and it is always due by 3:30 p.m., the same day that the assignment is due, so just keep that in mind. All right, so if you do not have the hard copy, but you would need to have a copy of today's notes, rather than printing out all 6 weeks stuff, this is just the notes for today. And I'm going to go ahead and attach it to the assignment as well. So if you take a look at the guided notes today, there are 4 pages. This is the first page, second page, third page, and again, the last page. So this is what we have. I'm going to go ahead and save this. as a PDF so that way you have access to it. So we're going to do this for algebra and paste PDF and save. Okay, so let's go back to MS Team and make sure that your assignment popped up correctly for Algebra 1 for week 2, Tuesday. And it did. And I'm just going to go ahead and attach their guided notes. Actually, that's not correct. Let's go back to this one. Here we go. Let's see. This is not. Hold on a second. It did not save accurately. Oh, so because it's still saving. So give it a second. I was like, this is not popping up. Okay, now it should be there. So let's give that one more try. And there's the attachment. So now you have access to it as well in case you want to print it out or something at home. If you don't want to print it out at home because you don't have a printer or maybe you don't have ink, like I don't have ink right now, you can come up to B1 Monday through Friday before 3 p.m. and then just pick up a hard copy. Okay, so you have your notes. Now let's go ahead and get started with today's stuff then. All right, so for your warm-up, take a look at the answers for this. You can go ahead and pause the video for a second and correct your warm-up. All right, let's go ahead and take a look at the breakdown for today. This is the breakdown of what we're going to be doing. We're going to talk about exponential growth and decay functions for day 2. I have a video that I want you guys to go ahead and start off with. So let's go ahead and take a look at that. So turn over to this page right here on your guided notes, okay? All right, so we're going to go ahead and get started with this one right here. First things first, okay? Would you go ahead, have 1 penny that doubles every day for 31 days, or would you take $1 million from me? Which one would you pick and why? Go ahead and pause the video and answer this question. Write your responses where the lines are. After that, I want you guys to go ahead and talk about which one is more by the end of the month. Do you think a penny that doubles every day for 31 days for a month or $1 million right off the bat? So how is this possible? So make a guess of which one you think it is and why do you think how it's possible? All right, now I'm gonna go ahead and have you guys watch the video with me on what choices you select. So would you take a penny that doubles every day for 31 days or $1 million? Which one do you think is a better choice? So hopefully you've already made your choices. You reflected on it. You wrote down your responses on the guided notes. All right, so you should be done with that. And let's go back to our lesson. So which one did you pick? A penny that doubles every day for 31 days or $1,000,000? Well, as a reflection, which option would you choose and why? And make sure you guys have justify your response. So if you take a look at this right here, at 27 day, you have $671,000. So it's not quite to a million yet, but on the 28th day, when you go ahead and double that, you've already exceeded $1,000,000. So then if you keep doubling this all the way up to 31 days, you actually walk away with $10.7 million versus just the $1 million. So as Albert Einstein said, the eighth wonder of the world is compound interest. So with that said, let's go on to the next part of this. I'm going to have you guys go ahead and turn over to this page right here. And we're going to go ahead and fill this part out. Okay, so it says study the data in the table determining the growth pattern for the population of fruit flies and fire ants, then use the appropriate operation to complete the puzzle. All right, so here is fruit flies and how they grow per week, and here are fire ants. So let's fill this part out. Between week 0 to week 1, you should have just one. Between week 1 to week 2, still just one. 2 to 3, 1, 3 to 4, still 1. So your first column looks like this. Now let's count the differences of the number of fruit flies. From 20 to 40, you get a 20. 40 to 60, it's a 20. 60 to 80, still 20 difference. And then 80 to 100, 20. So fruit flies only goes by 20 every single week. So then let's talk about fire ants. Okay, so week 1 to week 0 to week 1 is just 1. 1 to 2 is still a difference of 1. 2 to 3 is a difference of 1. And 3 to 4, difference of 1. But then let's take a look at the growth of the fire ants. So we start at 20, doubles to 40, so the difference is 20. 40 doubles to 80, so the difference is 40. 80 doubles to 160, so the difference is 80. And then 160 doubles to 320, so the difference is 160. The population of the two species of insect have different growth patterns. That's obviously true. So I want you guys to respond to this. Number 1A, how is the pattern of the change in the fruit fly data related to the shape of the graph? So what do you think the shape of the graph will look like if it's continually increasing by 20 every single week? Question B says, how is the pattern change of the ant data related to the shape of the graph? How do you think the graph will look like if the fire ants grow from 20 to 40, 40 to 80, 80 to 160? Draw two different graphs for me, one representing the fruit fly and the other representing the fire ant. So pause the video and do that. Okay, so what you should have said is that the flies has a linear growth, which is like a straight line. And that straight line will look something like this. And the ant has an exponential growth, which is a curved line that looks like this, because it's going a lot faster. Okay, linear or exponential? That's your next question. Johnny has an account at a local bank. The following table shows the amount of money he has in an account after X month. Graph the data. So what I want you guys to do right now is on the bottom, it is time, so 0. then 1, 2, 3, 4, and just go ahead and label that. On the vertical line, which goes up and down, this is going to be the growth in dollars. So we're going to say, since it's going to go from 1 to $81, maybe we can go ahead and count by, I don't know, maybe count by 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, and I can stop right there because the biggest one I have is 81. And we're going to go ahead and just graph that. So at 0, it's at 1, right there. At 1, it's at 3, right there. At 2, it's at 9. At 3, it's all the way up to 27. 4, it's all the way up to 81. So your graph, once you connect the dots, looks like this. Is a relationship a linear or exponential? How do you know? Go ahead and answer that. Pause the video and do that, please. Okay, at the same time, Allison decided to start an account at the same bank. She deposits $1 to the account and then add $20 to the account each month. Compare this table and show how much money Allison has in her account after X month. So she's gonna start off with $1 and then add $20 each month, okay? So then she's gonna add $20. So 20 plus 1 is $22. Then she's gonna add, oops, $21, just kidding. Then she's gonna add 20 more dollars. So then her account at month 2 is just gonna be $21 plus 20, so that's $41. And then month 3, she's gonna add another $20. So then her total here is gonna be $61. And next, $81. I want you guys to go ahead and graph that over here. And then tell me, is the relationship linear or exponential? And how do you know? Okay, next, I want you to go ahead and compare Johnny's and Allison's bank account. Which account has a pattern of growth and which one has a multiplication pattern of growth? So one is adding, the other one is multiplying. So does Allison or Johnny has a adding pattern or a multiplication pattern? Last question. How long is it going to take for Johnny to have more money in his account than Allison? And why do you think this happens? All right, you guys, after that, what I would like you guys to do is we're going to go back over here and you're going to be working on a Desmos activity. Your Desmos activity is kind of a long link. So what I'm going to do is I'm going to make it into a shorter link for you guys. So it's a little bit easier to manage and type in. So then looking at this right here, your link is right here where it says bit.ly/39KWV capital C capital F. If you go ahead and type that into your browser, it's going to take you to this page right here that looks like this. Okay, and there are 12 questions. So you're going to go ahead and get started with this. You can click on the first one and then just simply type in your answer for me so that way I can have it. But before you do that, make sure you have access to this. And what you want to do is once you go ahead and type that in and you have the link to this, you can go ahead and get started with these 12 questions. All right, so then if you're done with that, our last thing that we're going to be working on today is going to be right here. So this is an exponential function viral tweet. And it says, in 2016, Leonardo DiCaprio finally won an Oscar for the Best Actor in The Revenant. After years of being disappointed in the Academy Award, fans were thrilled to see him win, and the internet went crazy. Several memes went viral during the first 5 hours after the award was announced. Let's simplify the data and use what we know about the function to make some predictions. So when it comes to tweets, I want you guys to fill out the table. Left side is minutes, right side is the number of tweets. After you guys get this, go ahead and graph it. Then think about the data. Add up the number of new tweets from the total number of people who tweeted the meme, and then answer the following questions from this. All right, you guys, I will see you guys next time. As always, stay safe and healthy.